Not bad actually, because for the whole class, not bad. Because this was actual JEE mains questions. All the questions were actual. Yes. So this is your that moment. If you have ever questioned that why sir is he teaching all this, what is is he teaching, and where are we going with all this? If you have had all those questions, this is your answer to that. These were all JEE mains questions, and 80% of people who write JEE mains are not able to do that. So, Nehal, I don't know what you have done, but otherwise, accuracy is not all that bad when it comes to rest of the class.
Sir, but in the actual JEE mains, that would be time pressure also, right?
Yeah, those things will be there. That is true. See, it's not that easy. Yeah. Plus, there is one big difference. This topic, which I've been doing for 3 months, 4 months now, in fact. In JEE mains, it is just 1 week of syllabus. So when you actually prepare for JEE mains, this topic has only a week dedicated to it. I've been doing this for close to 4 months. Because there is so much to cover that there is only 1 week for this. Because there is so much syllabus that you can't allocate more than that for this. Pardon? What if you're studying from way before? Yeah, so that's what you have done actually by doing it in grade 8. Check. Doubts, please. Bhavya is asking second.
Sir, second one.
Come on, second one was as easy as any other question. You just didn't understand it. That's the thing. Otherwise, when you solve it, it's. See, position. Can you see displacement time or position time relation? You can treat them as similar. Okay. So this is, you can treat it like a position time relationship. Okay. Now, what is C naught and C? That's the thing. C naught and C are nothing but constants. Wait. C naught and C are constants. When I say constants, treat them like normal numbers, 1, 2, 3, 4, 5, like that. Okay. So now you expand it, C naught T square minus 2C. Okay. Plus C into T square plus 4 minus 4T. I hope this much is clear.
Sir?
Yeah.
Sir, isn't it supposed to be minus 2C naught?
Huh? Minus 2C naught. Oh yeah, sorry. Now I will arrange it. Normally T square has what? Can I write it as C naught plus C into T square by taking T square common between these two? Hello? Then for T we have only minus 4CT. We don't have any other term. For constant terms, we have minus 2C naught plus 4C. Okay. Remember, C naught and C have to be treated like constant. So C naught plus C is also constant. If C naught and C are two numbers, then sum of two numbers is also a number. Huh? No, but 4C is a constant. 4CT has a variable term T. T is a variable, but minus 2C naught and 4C are constant. Getting Bhavya? So now what is VT relation? Constant remains as it is. What happens to T square? 2T. 4C is a constant, it remains like that. T becomes 1. Constants, what happen? They become 0. Remember? So you got a VT relation which is C naught plus C, 2 into C naught plus C into T minus 4C. Okay. Now here what is AT relation, because the options are talking about acceleration. Except for T, this is a constant, so this remains as it is. T becomes 1. And what happens to 4C? 0. So you are left with A equal to 2 into C naught plus C. That's the answer. A.
Sir, don't we take common in minus 2 C naught plus 4C in the third step?
Where are you saying, Anish?
Sir, the last two terms, sir. Minus 2
What do
C
you
naught
want to
plus
take
4C.
common?
Sir, 2C.
No, 2C is not common. This is C naught, this is C. C naught and C are different. Yeah, you can take 2 common if you want. But C is not common, Anish. Hello?
Okay, sir. Yes, sir.
Huh? Show me. Yeah. Yes. Because C naught plus C is getting multiplied with T square. So how do you do that when you apply, like if it's 5T square, what do you do? You keep 5 as 5, this as 2T, that's how it becomes 10T, right? If that is a 5 is with T with a variable, but if it's just plus 5, then that becomes 0. Getting, Rudraj? Yeah. Show me where it is. No, you have to learn to deal with constants. I'm giving a question similar to this, guys. Okay. Yeah, A, B, C, D are constants. Yes. A, B, C, D are constants. Hmm? Kunal, all good? Both wrong. Okay, permanent constants that B and C, that constants or D does not become 1. They become 0. Who is this?
Oh, okay.
Nonsense, Arjo. No. Fine, Nihal.
Okay, sir.
Both wrong, Arihant. Who is this? Ashwik, it was a plus sign here. All signs are plus sign. I don't know how you are getting a minus sign. Permanent VT also you need to correct. Both.
Oh, yeah. Oh, sir. Sorry, sir.
Sarah, correct. Anish, correct. Who has not got?
Okay, sir.
Permanent still VT relation is wrong.
Oh, sir. I get my mistake.
Yeah, permanent.
Yes, sir. I'll make less mistakes now.
Who has not got? Akkad, Sharjo, Harsh, Rudransh. Who else? Acha, Arihant also has not got. Let's see. You have to gather the variables together. AT square is there. T is at 2 places. Don't worry then. So what does AT square become? A remains A, T square becomes. What does BT becomes? Silent, you are. Harsh, what does CT become? Akarsh, do you understand? What does D become, Akarsh? It? Oh, so 0. So you have V equal to 2AT plus B plus C. Arihant, do you get that?
Yes, sir.
Now A, what does 2AT become?
Sir, 2A.
What does BA plus B plus C become?
Sir, 0.
2A only, okay? So AT actually I should not have written AT like this. I should have given capital A here because small a was already in use. So I will just change it. Do you get it? This is just using because small a was already in use. So I'm using capital A. Got it, guys? Hello? Yes.
Sir, do we have to factorize the end result?
Oh, no, I don't think any factorization will be needed. Kunal, your VT relation is wrong because you have converted VT square incorrectly. And that is why final answer is wrong. See, this is correct, but what is this? I don't understand. You have to find time when acceleration is zero. Arihant, look at what the question is. And
Sir, I'm only getting till there.
Arihant, and also like when you go from V to A, why are you taking variables common? Why are you taking T common? If you take variable common, you are complicating it. Don't take variable common, then that way you will get a proper relation between AT.
Okay, sir.
You have to find what? Yes, where is time? And how is this equal to 2b? That side it goes and it equals to 2b. And time should be the subject of it. Sarah, correct? This is 380 only.
Sir, I'm stuck till where I sent.
How did 2b become 2bt?
Oh,
And then you have to make t as the subject, Parmana.
okay, sir.
Nehal, after this what? Stuck?
Yes, sir.
Okay, Anish, all logic is correct, but final answer is
So,
wrong.
sir, we need to make
Oh, okay, sir. Got it.
Ashwin, correct. Kunal, still final answer is wrong
Sir,
because
could you,
you can't take 3 common between 6 and 2.
sir, what is the mistake in mine? Anish.
That Anish, very silly mistake. I won't even tell.
Sir, where have I gone wrong?
Anish, I'm not telling you where you have gone wrong.
Sir, I sent.
Okay, sir.
You figure out. It's such a silly mistake. I expect you to figure out, Anish. That is why. Kunal, correct now. Aryant, correct. Hmm. Nihal, correct.
Okay, sir.
Yes, sir, I figured it out.
Yeah, Anish, correct. Who has not got this?
Sir,
Okay.
Paramanand.
Okay, don't worry, guys. So, what is VT relation?
Sir, V equals to 380 square plus 2BT
Wait,
plus C.
yeah. Harsh, any problems? Harsh, you tell what is AT relation. I'm using capital A. Now, what do we want? Time when acceleration is 0. So, A is 0. So, 0 equal to 680 plus 2B. Now, you need to make T as the subject because T is what you have to find. So, keep 680 equal to minus 2B. How do you get T alone? This gets simplified to. That's the answer.
Oh, okay, sir.
Arjav, okay, next doubt from the homework sheet.
Sir,
Sir,
sixth.
sixth.
People are asking 6th and 7th. Before 6th, nothing.
Sir, sixth.
Now 6th is now you should be able to do because again now you know how to deal with the constant variable situation. If you have not tried 6, not got 6 earlier, try now. You should be able to get it now.
Okay, sir.
These are two position time relationships. You have to tell when it has same, at what time it has same velocity. So find velocity time relationships for both and make them equal and then find time from that.
Sir,
Okay,
what
sir.
is B, like that kind of B symbol?
That's alpha and beta. These symbols, the symbol is called alpha. This is called beta.
Sir, is that XP into T?
Hmm?
Sir,
Ignore that, ignore that. It's saying position of P. See, there are
oh,
two buses, right? It is this XPT means position time relation for T. That's what
yeah,
they have
okay.
written shorthand. And this
Oh,
XQT means position time relation for Q.
oh, okay, sir.
Okay, that is why they are writing like that.
Yeah, I got confused because
And
of that.
this thing, see, what I give you is this. Listen, if you want to understand the notation, I give you this, right? but I have to
So you're not
separately.
showing.
Sir, you're not showing.
Sorry. What I am saying is that if I have to give you, I have given you something like this, right? Alpha t plus beta t square. Now there are two things different in their case. One is they are writing P here. You understood the meaning of P? That it is a XT relation for bus P.
P.
Now, why are they saying P here? Reason is, remember what Bhavya asked when I give this. She asked, sir, alpha and beta are constants or no? Now, how do they say that what is constant, what is variable? They say xt, this bracket represents variable. Okay. So when they say xpt, what do they mean? That it is a xt relation for bus P. And when they put t in the bracket, they are explicitly telling you that treat t like a variable. So automatically alpha and beta are constants. Similarly, this guy means xt relation for bus Q. And bracket mein there is t means they are saying treat t like a variable. So automatically f becomes a constant. Getting? So this is just mathematical notation. I explicitly write. They have written the same thing in mathematical language. You will learn. As you go along, you will learn these notations.
Sir, what does F stand for?
F is also a constant. Alpha, beta, and F are constants. Okay.
Okay, sir.
Just give me 2 minutes. I need to use the washroom and come. Yeah. 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 Okay, who has not got? I said if you got it, Joe. How after this magic happened?
Sir, I sent it.
It is, but who is that saying I sent it? Okay, Arihant, discuss with me.
Yes, sir.
Sarah, you also didn't get?
No, sir. Sir, if I'm adding a T, I'm getting a weird answer.
It's okay. Wait. Okay,
Here I sent it.
Sarah, what is VT relationship? VPT.
So it's
Anisha.
alpha plus
Yeah.
2 beta t.
Okay, what is VQT relation, Arihant?
Sir, it is F minus 2t.
Now you have to find that time when both buses have same velocity. So you will equate. Hello.
Yes, sir.
Now you need to get value of which thing, Arihant?
Sir, when both of them are equal.
No, value of what?
Of t.
Time, right?
Yes.
So bring all the time on one side and everything else on other side. Fine.
Yes.
Now again you need to get to a single t. How do you get to a single t? There are two t's here, 2 beta t and 2t. You can take t as common.
Yes, sir.
So what are you left with?
2 beta plus 2.
Equal to f minus alpha. Sarah. So now how much is t?
Sir, T is F minus alpha by 2 beta plus 2.
Now see, it is already matching one of the options. Look carefully.
Sir, D.
The f minus alpha denominator, you see it's matching or no? If you take
Yes,
2
sir, we
common,
can take 2 common.
it will become 2 times beta plus 1. Nihal, you get
Sir,
it?
in the answer key, it's showing wrong, sir. It's showing A.
No.
Sir, it is showing A, sir.
No, it's showing D only. 6D.
Oh, sorry, sir.
T, how does it become T plus 2? What happened to beta? Can you do that? Seriously? Ashwik. Next. 7th.
Sir, Santon.
Okay. Sorry. Look at it. They are saying which one is correct. So first of all, the position, velocity, and acceleration for a particle moving with a constant acceleration. Is any of the 4 cases acceleration time graph showing not constant acceleration? No. Okay. Now A equal to constant. Okay. So how will the velocity be? Think of it. A is constant. Okay. Let's say 2 or 3 or whatever. 2 is a constant. I'm just taking an example. What would V relation, VT relation be for you to get A as a constant? 2T? Yes or no? Getting? So if, do you get it? If to get A equal to 2, V should be of type 2T. Yes or no?
Yes, sir.
Plot V equal to 2T graph. It will be a line graph.
Sir, it's either B or C.
This is gone. Now a line graph also will be an increasing line graph if you plot V equal to 2T, or
Yes.
it will be a decreasing line graph.
Sir, increase.
So D also gone. Only these 2 options are left.
Sir,
Right.
the answer is C, right?
No. Now go to velocity. This represents velocity increasing or decreasing or constant.
Sir, increase.
It represents
Constant.
velocity increasing. If we look at this position time graph, because see, we are left with only these 2 choices. If we look at this position time graph, this represents what kind of velocity, constant or increasing? This increasing velocity. So this also rejected. acceleration.
Oh, okay, sir. Got it.
Sir, isn't the VT graph constant because it's a line?
What do you mean? VT graph constant? It's not constant. VT graph velocity is increasing. If you see, look, it's a line, all right, but that does not mean velocity is constant. Velocity is increasing. Acceleration is constant. Do you get
Okay,
it? But velocity,
Yes,
is it constant or
Yes,
it's
sir.
increasing? Check.
Sir, it's increasing.
And which position time graph? See, we had already rejected first and fourth. These two were remaining.
Yes, sir.
Among them, which one represents the velocity increasing? Means which position time graph tells you velocity increasing, this or this?
Sir, B.
So B is correct. Got
Sir,
it?
so the straight, yes, sir. So the straight line that is in the VT graph that represents the hidden acceleration part.
In a way.
Okay, sir.
Okay. Next. Huh? Who is that? Okay, Myra. Myra, eighth one you should have done. Like, I mean, I understand, sir. You don't even need to look at options, Myra. Look at it. You need to get an acceleration time graph, right? How have I taught you to get acceleration time graph from VT graph? Treat as if VT graph is a XT graph. I'm just copying it, but I will label it as XT. It is somewhat like this, Myra, right? So if this is the XT graph, do the velocity analysis in first phase. What is velocity, positive, negative? And increasing, decreasing, constant? Is it increasing? Constant velocity, right? So, and second phase, positive, velocity is positive and velocity is constant, right? So corresponding to this VT graph, in first phase, velocity constant and so constant and negative would look like this. Why? If it's constant, how can it be curved? If you curve it, does it really remain constant? For example, if its value was -2, does it remain -2? Constant by definition has to have a flat line. We will come to options. Okay. Second phase, what will happen? So somewhat like this. Now this and this guy, you might choose to connect or you might choose to ignore. Even if you connect, it will be not through a solid line, but a dotted line. We will see the options. So Myra, it's so AT graph should look like how? This only? We will see what you are talking about in options. So now I'm checking the options. This, okay, they have drawn solid, ideally they should not. But this cannot be correct, right? It is negative, positive, but then again negative, positive, so it is not happening. Only place which is matching ours is C. No, the line is not supposed to be solid. Their diagram is wrong. Even if it's there, it's supposed to be dotted line. Yes. No, not on a velocity time graph. Not in a position time graph. It is teleportation. So that's why position time graph you should have solid lines only. Velocity time graph, it makes sense to have dotted lines as well.
Sir, wait, sir, does that mean like the particle is here and then it like just spawns in the other point?
If it's a position time graph, then velocity time graph does not mean that. That just means particle's velocity was something and then it became something else suddenly. But position time graph, if you draw a dotted line, it means teleportation.
Oh.
Fine.
Sir, can really a particle teleport?
They do it all the time as per one theory. But let's not go. Anish, acha, you were not there in grade 7 with me, right? Chemistry, oh. So that's
Yes,
why
sir.
you are asking that. We have had discussion on that.
3 classes discussing these.
Huh?
We had 2-3 classes discussing electrons, whether they teleport.
Fourth dimension and teleportation and all. Anish, like this is not the right time for that discussion. Otherwise, it's one of my favorite discussions, teleportation. By nature,
Okay, sir.
matter by nature teleports. So it's what
Okay, sir.
nonsense is I talking about? And you know, one of the theory also says, you know what? That when you are falling, when something falls on ground, for example, pen falls on ground, actually it's not the pen which is moving towards the ground. Actually, it's the ground which is moving towards. Yeah, and that is proven. That is proven. That is a discussion for. I take special classes for that. Like when I say special classes, as in not like separately as part of the batch only during summer vacations for 10th graders, teaching them Einsteinian physics. Those classes are like not mandatory, they're optional. Huh? And yeah, one more thing, they're not paid, like as in that my students get access. And in fact, if you want, you can bring your friends along. It's like that. Yeah. If they are interested in knowing Einsteinian theories, general theory of relativity and special theory of relativity. And E equal to mc square. Huh? Because by that time you have learned enough physics to be able to understand all that. Right now, actually, for the first time, you're learning physics in my classes. In 7th grade, in name of physics, I taught math actually. And even in 8th grade, this time, no, it is math and physics both. It's not pure math, it is math physics mixed this time. After this, now physics you will read will be pure physics. So those classes will be there for you 2 years down the line. So by that time, you would have learned a lot of proper physics. You would be in position to understand. Because see, Einstein's theory of relativity, as relativity term comes, relativity, you need to understand relative motion very well for that. Now, you have actually learned relative motion in one dimension, very little bit. In grade 7, some relative motion problems did. Grade 8 also some relative motion problems with the help of straight line graphs. I have, but that's very basic relative motion you have learned. Relative motion is far more advanced topic than what you have learned. So once you learn that properly, then you can get into Einstein's theories. So that is the way it goes. That 9th grade, we go into advanced relative motion. And once 9th grade ends, then 10th grade summers, I teach theory of relativity.
Also, sir, it's on book I read that there will be two particles you sell out there. However, you spin one and the other will start spinning in the other.
Yeah, that's called quantum entanglement. But that is a different theory to Einstein's theory. Einstein actually dismissed it as a crap.
Yeah, I know. It was never very short. It's still made it.
That Einstein didn't believe in that. So I'm not talking about quantum entanglement or quantum physics here. I'm talking about theory of relativity when I say that. Although bit of quantum I will teach in grade 10 as part of main batch. That class will not be optional. Whatever is there in basic JE syllabus, whatever basic quantum physics is there, that I will teach.
Just one.
Yeah, there is a bit of, very small bit of quantum physics in JE. Like there is one very famous equation called Schrodinger equation. That, no, Schrodinger's cat is related to that, yes. But Schrodinger's equation is tightly related to quantum physics, basically. So that one topic, Schrodinger's equation, is there in JE syllabus. So that when we do. I don't have it my way, but if I really have it my way, just one thing, I would close all my classes and only run 2 batches, one for IOQM and one for all this quantum physics, Einsteinian physics and all. That's it. That is
So what do you
if
mean?
I have it my way, but I don't have it my way. That's the
So what
thing.
do you mean by you don't have it your way?
See, I am not just a teacher. I am also a service provider, a businessman. When I say service provider, businessman, I mean I teach, but I charge for that as well. Money is involved. So I need to teach what people are asking me to teach. Now, IOQM is still okay, reasonably popular, but Einstein's theories or quantum physics, nobody wants to learn basically. Or people question that how will it help me in JE? And I have no answer to that. It won't help you in cracking JE and Einsteinian theories or quantum physics and all, except for small part of Schrodinger equation. It won't really help you. People question that in IOQM as well, but there I don't care if they question. It's obviously it helps in JE, but Einsteinian physics or quantum physics, so I can't even justify saying that it helps in JE. So, okay. So yeah, next bit. Listen now. You have learnt about average velocity. Okay. Now, average velocity, what you have learnt is total displacement by total time. Now comes average velocity part 2. For that, I have a simple question. Okay. And I will take this class example. Who loves to eat here in this class? Abhiram? Okay. What do you love to eat, Abhiram? Huh? Chicken biryani. Okay. Okay. Now this is something you have to tell me immediate answer. Okay. No calculations, pens down. I want immediate answer for it. Okay. First, I will ask a simple question. So Abhiram, on day 1, he ate 1 chicken biryani. Okay. On second day, so this is first day. Okay. Second day, he ate 2 biryanis. Third day, 3 biryanis. Fourth day, 4 biryanis. Pens down, guys. Try to answer without. Fifth day, 5 biryanis. Sixth day, 6 biryanis. Seventh day, 7 biryanis. Okay. What was his weekly average per day biryani eating? What was his average? What is that?
Sir, 4. Sir, 4. Sir, 4.
Anish, 4. What?
4.
4?
Sir, 4.
Right. It was 4 biryanis. How did you really calculate? Huh? Acha, you calculated.
Sir, 28 by 7.
But notice one thing. Okay, even if you calculated, it is 28 by 7. But look at it. You cut first, second, third, and fifth, sixth, and seventh day. The middle term came out as the average.
Sir, that's what I mean. Sir, median.
Median came out as the average. Okay. I am coming to that. Okay. This you get it? Hello?
Yes.
Now, let's change it a bit. First day, he ate 1 biryani. Second day, 2. Third day, 3. Fourth day, 4. Fifth day, 6. Sixth day, also 6. Seventh day, 7. Now, what will be his average? Will it be average biryanis per day?
Sir, something around 4.
29 by 7. So 29 by 7.
It will actually be 29 by 7.
Sir.
Look at it total. How many biryanis he has had? 1 plus 2 plus 3 plus 4, 10 plus 6, 16 plus 6, 22 plus 7, 29 biryanis over 7 days. Does it come the median number this time as well? No. Okay. So notice one thing. If his biryani count is increasing in a constant manner, 1 biryani, 2 biryani, 3 biryani, it was increasing in a constant manner, right? There was no blip. Then the median becomes the average. Yes or no? But here it was not increasing in constant manner. I mean, first 4 days it was constantly increasing. But fifth day from 4 it directly became 6. And sixth day it didn't increase at all. It remained at 6. So there was not a constant increase. Yes or no? Hello?
Yes.
So what is the observation? Observation is,
Sir,
1 minute, Bhavya. Let me write it down then. A constant increase results in average being equal to middle term or median. Also called median. Right? Yeah, Bhavya.
the total
Then also.
the average of the medians.
Yeah, then you will get 2 medians. You take average of medians. That's what will, that also counts. Yes. I was thinking you will ask that, or somebody will ask that.
It's only constant increase, not decrease. It will be like constant change.
So what happened?
Okay, nothing. Okay. Got this so far? Hello? A constant increase results in average being equal to middle term. Now, this is a very important observation. Imagine this. Let's say you are given a VT graph. Then also, but a constant decrease.
Just a constant change.
Now, does this represent a constant increase in velocity? Let's say
No.
initial velocity was 0 meter per second, and after 5 seconds, the velocity became 20 meter per second. Is the velocity increasing constantly?
Yes.
Yes, sir.
So then average velocity during first 5 seconds,
So
during 0 second to 5 second is?
four
No.
meters.
No. We are not doing displacement by time because it's a VT graph, we don't have displacement. But we have velocity. This should directly give us velocity, right? So direct velocity has increased from 0 to 20 and it is a constant increase. So average velocity is middle of these values, which is
So 10.
10 meter per second. The median value between, so what odd number can't have a median value 0 to 21 if it was. What lies between 0 and 21?
So 10.5.
10.5. Getting? Hello?
Yes, sir.
But
So
this
then the
happens
time which
only if VT graph shows you a constant increase in velocity or a constant decrease in velocity. If it's a non-constant, for example, if it was like this, okay? In this case, average velocity, can it be found or no?
sir, no.
No. The average velocity is not equal to median or no in this. It can be found, actually there is a way. If the equation of this curve is given, there is a way using calculus to find it. I'm not going there right now, but you get it that it will not be the median term or it will not be equal to 10 meter per second. Hello?
Yes, sir.
Why will it not be the middle term? Because the increase or change is not constant. Okay? Hello?
Yes, sir.
So let's say this is the VT curve, sorry, VT graph. Now tell me this. 20 and that changes to 10 meter per second. 0 second, 10 second. Find average velocity between 0 second and 10 second.
So should
So
we
do we have to send you?
Yeah. Yeah. No. Anish, correct.
Okay, sir.
Sara, correct. Parmanand, correct.
Mama.
Correct. No. Correct. No. Correct, Abhiram. Correct. Correct. Arihant, correct. Nihal, correct. Guys,
Okay, sir.
what lies between 20 and 10? 15. So 15 meter per second. If you are confused how to find median, you can just do start plus end by okay. This is only if increase or decrease in velocity is constant. If VT graph is a straight line. If it's not a straight line, this does not work. Okay. Hello.
Yes.
Now, if you understand this, you can do something magical with this. A VT graph can give you acceleration that we have learned. Yes or no? But VT graph can also give you displacement. How? Look at it. In this case, you have already found average velocity, 15 meter per second. Now go to the other formula for average velocity. It is equal to total displacement by total time. Now, what is the time passed in this velocity?
10 seconds. 10 seconds.
10 seconds.
Equal to total displacement by 10. So total displacement equal to
Sir, 150 meters.
150.
Sir, it's
That's
not
a-
meter per second.
sorry,
Sir, it's
150.
not meter per second.
Sorry. 150 meters. So a VT graph has helped you find total displacement.
Sir, this only helps us when the VT graph is a straight line, right, sir? Sir, this only works if the VT graph is a line graph, right, sir?
Yes.
Okay, sir.
See, Anish, it works only if VT graph is a straight line, right? And you
Yes,
are
sir.
right as well.
Yes, sir.
And we will use it that way. But there was a genius by the name of Isaac Newton who said, even if it's a curve is made up of multiple straight lines. So he made it work for a curve as well. Using,
Sir, is it the same way like m minus delta, m plus delta, that one?
yeah.
Oh, okay, sir.
Pardon?
Sir, can we do this next class?
Can we do this or something else next class?
Sir, I mean like whatever you're doing now, because like we have school tomorrow.
Okay, I'm asking last question of the day. 150 meters. Thanks, actually. Find total displacement for first 20 seconds. What is this? Minus 10 and 20 was there, right? Sarah, correct, you may leave.
Okay, sir. Bye, sir.
Parmanand, correct, you may leave. Ashwik, correct, you may leave. Ashwik, actually, your mom has. No, it's raining, I think, so she will. Correct, Rudransh. That was Arjav, okay. Kunal, it's wrong. You are finding average velocity incorrectly. Wrong. Average velocity is the time is how much? See, 20 seconds is the time. Correct. Average velocity is wrong. Yeah. Yeah. Wrong. That is this is correct. Show me again. What is the average velocity you are finding? Aryan, correct? Yeah, I will. Yeah, I think you should call her. But wait a minute. Okay, let me. Aryan, correct? You may leave. Anish, correct? You may leave.
Okay, sir.
Bye, sir.
Bye, sir.
Correct, Myra. Correct. Right. Right. Okay, Kunal, you are done, right? No, it's
Sir, I
not.
sent the answer. Sir, I sent.
Correct, Kunal. You may leave, Kunal.
Okay, sir. Bye, sir.
Nihal, average velocity is wrong. Minus 10 and plus 20. What is between them?
Oh, sir, got it.
Average velocity is wrong.
Sir, I sent.
Okay, let me call. I think that might be her old number. Let me call them.
Sir, I sent.
Sir, I have the updated number on WhatsApp. What is the answer, Nihal? You can tell.
Sir, 60.
No. Yeah.
Sir, sorry, 100.
Yeah. Yeah, you can unplug that one white one.